I will tell you about the calibration of voltmeter by potentiometer. It is the fifth application of potentiometer. For that, this I have told you the comparison of EMF of the primary cell of two primary cells, internal resistance of the primary cell, measurement of the small resistance, and the measurement of thermo EMF. The fourth and the fifth one is this, the calibration of voltmeter by means of potentiometer. I have told you about the standardization and that the calibration, that why it is necessary to standardize the potentiometer, and also what is the meaning of calibration. So, the calibration means to check the accuracy and correctness of the instrument by means of potentiometer or with the reference instrument. So now the question in the board exam is asked like this, that what is the meaning of calibration? First thing is, what is the meaning of calibration? And then they ask the circuit diagram for the calibration of voltmeter or ammeter. And then they ask the working of the calibration. This the question that carries the 4 marks. One, for the definition of the calibration. Second, the electrical circuit, 1 mark, and the working, that is now 2 marks. So this is 4 mark question. If suppose question is of 3 mark, then only the definition of the calibration and then the electrical resistance, and ask about the calibration curve. So this may be the question of 2 marks or the question of 3 marks. So different type of questions can be set from this calibration of the voltmeter and the ammeter. So now let us take the calibration of voltmeter by potentiometer. Calibration of voltmeter means to check the correctness or accuracy of voltmeter by potentiometer. This is what the meaning of calibration. Now I am telling you the circuit diagram. This is the main circuit. Then we are having a standard cell. Its EMF is E0. is a galvanometer. जो कि J. Here we have a resistance box and this is the galvanometer, the voltmeter. Like this. R is this. Now conjugate this. This is now E. This is now current in this circuit. This is your X, Y and Z. This is not two-way key. This is the circuit diagram. This is now voltmeter circuit. Voltmeter circuit. This is the complete circuit diagram for the calibration of voltmeter. This is the main circuit. As I have told you that there is no change in the main circuit. The change is made only in the auxiliary circuit. So this is the auxiliary circuit. This is the standard cell of constant EMF E naught. This is now two-way key X, Y, Z, two-way key. Now this is now resistance box. This is now voltmeter. So this is your positive and negative. And then this is now rheostat RS dash and the key K dash. This is now a primary cell. And in this way the circuit is made. So first the current is passed in the potentiometer wire AB from the main circuit. This is now circuit diagram. Circuit diagram. The current from main circuit is passed through potentiometer wire AB. Potentiometer wire AB. So this is the first step. Whenever we are going to have the experiment with the potentiometer, then always first pass the current through the potentiometer wire, so that there is a potential drop across the length of the wire. Let E naught equal to EMF of standard cell. And I have told you that standard cell is taken either it is a cadmium cell or this is the Daniell cell, because these two cells have the constant EMF over a long time till the experiment is continued. By connecting x by the balance length is obtained by sliding the jockey on the wire AB such that the balance length is maximum. It is done by adjusting the rheostats in main circuit. इन मेन सर्किट सो हम इसको एडजस्ट करते हैं जिससे कि इसकी जो लेंथ है वो अधिक से अधिक आ सके. तो इससे क्या होता है कि दैट यू हैव स्टैंडर्डाइज्ड द पोटेंशियोमीटर. सो द पोटेंशियल ग्रेडियंट x equal to E naught upon L naught. L naught is the balancing length where L naught equal to balance length. This we have standardized the potentiometer. Thus potentiometer is standardized अब इसके बाद क्या करते हैं हम इस RH को बिल्कुल भी डिस्टर्ब नहीं करते, अदरवाइज दिस विल चेंज एंड ऑल द रीडिंग्स विल चेंज. सो दिस इज केप्ट कांस्टेंट. Now after that what we will do, that this x by will be disconnected and by z will be connected, so that this voltmeter circuit is in the circuit of the potentiometer. Now this is the first step. Now second step. The by z is connected after disconnecting the x by. disconnecting the XY, so that voltmeter circuit, voltmeter is taken in potentiometer circuit, in main circuit. In main circuit, the current is passed in voltmeter circuit and a resistance R is introduced by means of resistance box. So what there are number of caps or the number of plugs. One of the plug is taken out, so the current passes through the resistor. Inside the box, that resistance is introduced. So there is written the 1 ohm, 2 ohm, 3 ohm, and then 10 to 100 ohms. So you just insert any of the resistance, either it's 1 ohm or 2 ohm or 3 ohm. So after this, our next step will be this, that the voltmeter is taken into the main circuit. So and then current is passed in the voltmeter circuit and resistance R is introduced. This is what the voltmeter is taken into the main circuit. For different readings of voltmeter, the corresponding balance length is obtained by sliding जो कि J on the wire AB. तो जैसे आपने वोल्टमीटर की रीडिंग ले ली, जैसे सपोज दिस इज 0.1 volt, then find the corresponding length. Suppose 0.2 volt, then find the corresponding length of the potentiometer wire and go on increasing this the voltmeter reading and find the corresponding balance length of the potentiometer wire. So there are not two readings, one reading from the voltmeter and second the reading from the potentiometer. So let V equal to reading of voltmeter and L equal to balance length, then the potentiometer reading potentiometer reading, this V dash equal to X into L. X is from here, E naught upon L naught. So this V dash equal to E naught upon L naught into L. This is the potentiometer reading. This is the true value. The potentiometer reading is the true value, actual value. So now error is delta V equal to V minus V dash. The value measured by the voltmeter and that's the value taken by the potentiometer. So this a calibration curve is drawn between delta V and V, the error and the voltmeter reading. So this is zero. Here we have this x-axis, this is now your y-axis. Here we take this delta V. This may be here also because delta V may be negative, positive and 0. Here we take this B. So we are having this like this. This is the, here we are having this V on this x-axis. So this gives you the calibration curve. From this calibration curve we can calculate the value of the potentiometer. The calibration curve gives the value of potentiometer. Reading corresponding to given value of voltmeter, given reading of potentiometer of voltmeter. So this is how the calibration of voltmeter is done with the help of the potentiometer. When this is found that the error is very less, or we are having the error is 0, then instrument is supposed to be a very good instrument, and then this is allowed to sell in the market. The company whichever manufactures it, first all the instruments like voltmeter, ammeter, and that wattmeter, and so many other instruments, they are first calibrated by the potentiometer. I have told you that the potentiometer is used for the calibration because this is an ideal instrument which gives the correct readings, and this is also a very sensitive instrument for the measurement of very small potential differences or the EMF of the cells. So this is about the calibration of the voltmeter. Thank you very much.